Product design. As a design stage, detailed specifications are provided so that manufacturing can produce what has been designed. This means not only providing dimensional specifications but even specifications regarding capacity, horsepower, speed, color, etc. are laid down, and the task of manufacturing is to convert the design into physical entities. Product varieties. There are two distinctly different priorities that can affect the design of the product or the services. The higher the standardization, the greater will be the ease in producing. On the other hand, customer have different needs, and by adding variety, one can satisfy more customer. Standardization attempts reduction in variety and better use of productive facilities, thereby achieving lower unit cost. If the demand for the product or services is strong when the price is low, organization will try to minimize unit cost through standardization, and most of the competition will based on prices. There are other cost related advantages due to standardization. It simplifies operational produces procedures and thus reduces the need for money controls. The organization can buy raw materials and components in bulk and thus get quantity discounts. It enables steady flow of materials through work in centers and thus reduces the number of production sets ups related to change in flow. It reduces the total inventory of raw materials, work in process, and finished goods. Finally, since the effective volumes becomes larger as the variety is reduced, high volume productions method become viable, thus giving economies of scale in production itself. The standardization is very useful concept, but production needs have been given the highest priority in this scheme of things. This may be a very good approach to product design as long as cost is primarily basis of competition. Otherwise, we can design a product to suit the diverse needs and tastes of the customer. All watches are meant to display the right time, but still company like HMT has hundreds of models of watches with different movement, dial shapes, sizes, and other features. By adding variety, and organization attempt to satisfy the varied needs and tastes of its customer and completes non price considerations as well. The other one method used to obtain variety of or perceived variety and yet hold down cost is through modularization. A product is designed using module or sub assemblies that are interchangeable, and each different combinable of modules gives the new variety of the product. For example, two different movements, three dial shapes, two dial sizes for each shape, and three different colors will give two 2 by 3, 2 multiplied by 3 multiplied by 2 multiplied by 3, that is 36 variant of watches, yet making large quantities of standard modules. Design implication attempts to simplify the design so that produce the product or its parts becomes similar to produce. This might mean combining two or more parts into one so that some assembly operations are eliminated. In some other situations, it might involve replacing screw fastened parts by parts which can be snapped tight in place without any fasteners. Design simplifications gives pay off the term of lower production cost and in some cases by lower material cost as well. Structuring of options. Options provide variety to product, increasing its attractiveness to a spectrum of users while retaining operations as different as simple as possible. We can see options products everywhere, for computers and office furnitures to automobiles and machine tools. Even service have options built in. For example, in vehicle insurance. Structuring the operations is a major part of making a product line competitive when not competing on cost alone. However, options bring in their own complications as well. For example, pricing becomes much more complicated since each options may not have the same margin. A lot of sales effort is required explaining options or determining what the customer wants, and it complicated the customer's choice. Options also gives the customers an opportunity to change their mind, and this creates additional difficulties other the products is made to order. All options are not used to the same extent, and low uses option parts becomes hard to plan and control when mixed with a high uses option part. CAD CAM. A part can be computer designed, computer aided design, and its fabrication instructions can be generated by computer aided manufacturing. CAD CAM. This has advantage that manufacturing equipment is not tied up for long period during setting up time. Practically all the preparation time is in programming, where detailed instructions regard to the physical task to the performed and sequence in which these have to be performed are operation written into the program, which can be read and executed by the computer having the machine tools or any other manufacturing equipments under its control. This then allows for every small batch size without losing an economy. Finally, because information regarding the design and the manufacture of the product and component is available on computer files, it is possible to use the data together with the other information on materials, tools, etc. for producing, planning, and control purpose, thus achieving computer integrated manufacturing (CIM) that has great importance for the future. CIM is not yet a reality, but is certainly the direction towards which manufacturing in some industries is proceed. Design characteristics and trade-offs. By now, it should be quite clear, and there are many product features which can be affected by product design. In fact, operations management normally has a major role to play while final products characteristics are set. The key elements to be considered in product design are: a. Function. The new design must properly meet the recipient need and perform the functions for which it is designed. B. Cost. The total cost incurred in producing the new idea should not be excessive, else that will affect its demand. C. Quality. The quality of the new design should be as high as possible within the constraints of the cost. Quality can cost money, and excessive quality will increase the cost and reduce demand, whereas inadequate quality will affect the performance and lead to complaints and falls in demand. D. Reliability. The new designs should function normally without failure for the expected duration. This is more important for complex designs involving many elements, and the design must provide the redundancies and high reliability of elements so that high system responsibility reliability can be obtained. The other elements which are also important in a production design, perhaps to a lesser degree, are E. Appearance. If the new design can be made more attractive without sacrificing on the other attributes, this is only likely to improve the demand. The relative importance of appearance varies from product to product, and in many industrial equipments, it may have a relatively small effect. F. Environmental impact. The new design should not degrade the environment. G. Product safety. The new design should not pose a hazard to the recipient. H. Productivity. The new design should be producible with ease and speed. I. Maintainability. This is particularly appreciable to the customer durables and industrial equipments. If a failure occurs in equipment, it should be easily reliable with a minimum of downtime. J. Timing. This is particularly relevant for design of services. The services should be available when desired by the recipient. K. Accessibility. This element is also applicable to services. The recipient should be able to obtain the services without difficulty. The last two factors are important for design of services since services cannot be inventorized. In both production and service design, many alternatives usually exist that will meet the basic functions of the output. The design task is to recognize the major characteristics of the demand and to carry out a detailed analysis of the trade-offs available among the various design alternatives so as to meet the needs of the recipient as closely as possible. Sometimes, when the needs of the recipients are diverse, design will produce different models of the versions of the same basic product to satisfy the needs of the different segments of the market. This can be seen from the various models of television produced by almost every television manufacturer, or the economy and the executive classes of air travel offered by the Indian Airlines. The impact of product innovation or process innovation. The design of a product or services has very close linkage with the design of the process required to reduce it. In some cases, the product design itself becomes feasible only because of the technical innovation. Throughout the product life cycle, the process of product development goes on, and we have looked into these aspects in section 4.4. It has been found that similar innovation take place in a process design as well. Product innovations are primarily needs simulated, and the emphasis in the maximization of product performance. The process typically uncoordinated in the stage, and process innovations are primarily output rate stimulated. Product innovations are gradually decreasing while process innovations picked up at this stage. In stage 2, both product and process innovations are technology simulated. The productive market design emphasizes cost minimization as competition in the market begins to emphasize price. Process innovations started dominating over product innovations as they yield greater reductions in the cost. The product or services has reaches maturity and saturations by the third stage, and innovations are stimulated primarily by cost consideration. The productive processes becomes higher integrated, and product focused operations try to achieve economies of scale by having integrated plans of large capacities.